Hi everyone, I hope you're okay, and I hope that guys the videos will keep uploading and helping you out. In this video guys, I'll be just focusing on momentum and impulse. It's just a short topic guys, so please don't expect a long video. Let me just give you a brief explanation. Okay, momentum. What's happening? Let me change this. Excuse me. Okay, momentum. Né? Momentum by definition is just the product of the mass of an object and its velocity are together. If you have the mass of an object and its velocity, you can simply calculate the momentum. Momentum is equal to the product of mass and velocity are together. So momentum, guys, is always in the direction of a velocity. Why am I saying that? For me to find momentum, I'll be multiplying mass, which is a scalar quantity, and the velocity of an object, which is a vector quantity. Whenever you multiply a scalar and a vector, you will always get a vector. So it's very important to know that momentum is a vector quantity together, and it will always be in the direction of the velocity of an object together. And then the second part, which is the most important part I want us to deal with, is the conservation of linear momentum. The conservation of linear momentum simply tells us that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Conservation of linear momentum. It simply states that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Right together. So if we have position A and position B over here, you can simply say that the sum of all the momentas at position A has to be equal to the sum of all the momentas at position B. Right together. And this is the case if and only if we have an isolated system. What is an isolated system? An isolated system is a system that does not have non-conservative forces together. In an absence of frictional force, applied force, or tension, we don't have Norman. In an absence of frictional force, applied force, and tension, we have an isolated system together. And if the system is isolated, you can simply conclude that the total linear momentum will be conserved together. And then now let's deal with impulse. Okay, by definition, what is impulse? Impulse is the product of the net force acting on an object and the amount of time it takes to act on an object together. So basically, impulse is just equals to F net delta T together. But we know that from the second law of Newton that F net is equal to the change in momentum all over the change in time together, and F net delta T is also equal to the change in momentum. So we can therefore conclude that impulse is equal to the change in momentum together. And always the time, guys, whenever they ask you to find impulse, you must always give the direction, right? We are multiplying a vector and a scalar quantity. It will result to a vector quantity together. And the SI units for impulse will be Newton seconds together. So it's very, very important to know the SI units and also to write down the direction, because impulse is a vector quantity together. And then the last part I want us to deal with is the types of collisions we have whenever we deal with momentum and impulse. There are only two types of collisions that we deal with, guys. The first one is an elastic collision. Second one is inelastic collision. For elastic collision, guys, just know that kinetic energy has to be conserved kinetic energy before collision must be equals to the kinetic energy after collision. Are you together? But for inelastic collision, the kinetic energy before collision must not be equal to the kinetic energy after collision. Are you together? So if kinetic energy before and after collision is conserved, then we can conclude that we have an elastic collision. But if the kinetic energy before and after collision is not conserved, therefore we have an inelastic collision. Basically, guys, that's all you need for momentum and impulse. That's all you need. So let's just do one typical exam question. One typical exam question. In the meantime, guys, I hope you are subscribing there. Where will I find these exam questions? Okay, here are my files. Downloads. Okay, there's a question there I want us to attempt, and that's question number 5 from the 2024 June examination. Okay, we are told that a truck of 1,500 kilograms is traveling at a constant speed of 20 meters per second to the west along a straight horizontal road, and it collides with a stationary car of mass 900 kg, and the two vehicles move together after collision. The collision lasted for 0.2 seconds. You must ignore all the effects of friction. The first thing I want us to do is to choose a positive direction whenever we deal with momentum and impulse, right? Since this car is stationary and this is the only moving car, I'm going to take any movement towards the west or the left as positive. Are you together? Any western movement has to be positive. Are you together? And if I can call this object A and this one object B, I know that the velocity for object B is 20 meters per second. The velocity for object A before collision, it was stationary. This is 0 meters per second. And then obviously after collision, the velocities of both A and B will change. Are you together? Okay, now they want us to explain what is meant by the term isolated system. Isolated system simply tells us that we don't have a presence of unbalanced forces. Basically, we don't have frictional force, applied force, or tension. Are you together? We don't have non-conservative forces, and hence we will have an isolated system. Are you together? And then 5.2, we must state the principle of conservation of linear momentum in words. It simply states that in an isolated system, the total linear momentum is conserved in both magnitude and direction. Okay, then 5.3.1, I'm being asked to calculate the speed of the vehicles after collision. Remember that after collision, these two vehicles will move as one unit. Né? So since there's no force applied and there's no frictional force, we can simply say that the sum of the momentas before collision is equal to the sum of the momentas of the two objects after collision. Né? To momentum of body A and momentum of body B. Né? For the momentum of body A, it will be the mass of body A multiplied by the velocity of body A initially plus the mass of body B multiplied by that of body B just before the collision. After collision, I know that they will move as one unit, so I'm just going to add their masses and then multiply by velocity. Okay, for body A, that's our car, which was stationary. Its velocity was 0 meters per second. And then we had our truck, with a mass of 1500 kg and a velocity of 20 meters per second. And then we have 900 plus 1.5 kg multiplied by the velocity. On the left hand side, I'll simply have 1500 times 20. This will give me 30,000. And then on the right hand side, 900 plus 1.5, this is 2,400 together. Then I'll say 30,000 divided by 2,400. Then the velocity of the combined units is just 12.5 meters per second towards the left, but they wanted us to find the speed, so the direction does not matter. The speed is just 12.5 meters per second. Okay, and then now they want us to calculate the net force exerted by the truck on the car. The net force exerted by the truck on the car. Okay, we can simply go to our impulse momentum equation. F net is equals to the rate of change of momentum, or F net delta T is equals to the change in momentum, and then F net is just equals to the change in momentum all over the change in time. I'll use the 900 for the car. The final velocity, that's 12.5 minus 0 all over 0.2. The collision lasted for 0.2 seconds. It was stated on the statement below above. So for me to calculate the value of the resultant force, I simply have to say 900 multiplied by 12.5 minus 0 all over 0.2. This will give me 56,250 newtons. So I now know that the net force, the car will exert a net force of 56,250 newtons west. Are you together? If you wanted to, guys, we could have used the information of the track as well. I know that F net would have been 1,500. The final velocity was 12.5. Initial velocity was 20 all over 0.2. 1,500, 12.5 minus 20 all over 0.2. We still get the same answer, but it's negative 5250. This guy this should simply remind you about Newton's third law, that if body A exerts a force on body B will exert an equal but opposite force. This negative here just tells you that the force is being exerted on a different direction. Are you together? So whatever way you chose to calculate, it was going to be up to you. Okay, and then now I'm being asked, is the collision elastic or inelastic? Use relevant calculations to explain your answer. Okay, I must find the sum of the kinetic energies before collision. This will be 1 over 2 kinetic energy of body A plus the kinetic energy of body B. Okay, the body A was stationary, guys, before collision. So if it was stationary, its velocity is going to be 0 meters per second, and hence the kinetic energy is going to be 0 joules. Plus 1 over 2 multiplied by 1,500 multiplied by 20 squared. Okay, this will give us 1 over 2 multiplied by 1,500 multiplied by 20 squared. This would give us 300,000 joules before collision. Now let's find the sum of kinetic energies after collision. Remember that, guys, after collision, both the car and the truck, they moved together as one unit. So I'm just going to add their masses and multiply by the final velocity. That's 1 over 2 900 plus 1500 multiplied by 12.5 squared. 1 over 2 900 plus 1500 multiplied by 12.5 all squared. This will give me 187,500 joules. We can see that the sum of kinetic energies before collision is not equal to the sum of kinetic energies after collision. So this collision has to be inelastic. Are you together? Why? Because kinetic energy before is not equal to the kinetic energy after collision. Are you together? And then for the last question, we are being told that delicate equipment is usually packaged using bubble wraps. Okay. Delicate equipment is usually packaged using bubble wraps for safety of the equipment. Explain the process. Okay. The packaging, guys, of a bubble wrap gives a softer surface. Are you together? Such that if there is a collision, are you together, the time of contact will be prolonged. Are you together? And hence the force exerted by the equipment will be lower. Why am I saying this? Because remember that F net is equal to the rate of change of momentum. Rate of change of momentum. Ne? So the more you prolong the time, remember that F net in this case is inversely proportional to the change in time. If you increase the time of contact between the time of contact, you are literally decreasing the resultant force exerted just to protect the delicate equipment. Are you together? So bubble wraps are used just for this function, to increase the contact time and by decreasing the resultant force. Yeah, that's how, guys, you're supposed to answer this question. Obviously, after after taking in the knowledge and momentum, ne? You approach questions like this, guys. Nothing more, ne? Just stay tuned, guys. A lot of videos will be coming towards you. In total, there will be plus minus 10 videos where I'm answering past question papers just for you guys, ne? Just stay tuned, share the video to your peers, subscribe. Thank you.